7.3 is on solving equations using what's called W-substitutions. Okay, so these equations are called equations of quadratic type. Okay, so it's very strange. A lot of them are going to look really, really weird. So if you look through your notes and you look at something like number 6, does it make you have like fear in your heart for a little bit? Are you like, oh my God, we're going to learn how to solve this? Okay, we're going to do something where we substitute something in. It's going to look much simpler, and then we can solve it. Okay, so that's our goal, to take things that look like number 6 and to make them look easier. So the first thing we're going to do, we're not going to solve these first few, but we're just going to try to set them up using W's, so doing a substitution with W's, okay? So something like 2x to the 6 plus x cubed plus 9. What I'm going to do is I'm going to let my W equal x cubed. And my goal is to get it to be a quadratic equation. So this is a quadratic equation right there. So something times w squared plus b times w plus c. So if I let w equal x cubed, when I square both sides, what is x cubed squared? That's x to the 6th, right? So what I'm able to do then is I'm able to replace my x to the 6th and my x cubed with w's, okay? So the x to the 6th is replaced with what it's equal to. So it's equal to x, or w squared. And then the x cubed is replaced by what it's equal to, which is w. And then we have 9. Do you guys see that? So it seems pretty weird to do this with something simple like that, but we're going to get more complicated, like I said. So what do you guys think our w is going to be for the next one? Yeah, x to the 5th. Do you guys see when you square the w, you get x to the 10th? That's the other thing in the equation, okay? So we have x to the 10th, we have x to the 5th, and now we're going to replace them with their equivalents with w's. Yeah.
I'm confused on how you know what you let w do.
We'll see if there's a little pattern. I think there's a pattern. Okay, so here we have 7. Yeah, it's kind of the middle. So we're going to have 7. This one was w squared. This was w plus 6. Exactly. You get it? So any guesses as to what the next w is going to be? X to the 1/3. Notice how I'm not saying 2x to the 1/3. I'm just saying the part with the power, the x to the 1/3. So we're going to let w equal x to the 1/3. We then square both sides. So when I take x to the 1/3 and I square it, I multiply my powers. So multiplying 1/3 times 2 gives 2/3. So I have x to the 2/3. I then rewrite, so I'm going to have x to the 2/3. Well, that's replaced with what it's equal to, w squared. I get plus 2. X to the 1/3 is replaced by w, and then minus 4. Does this make sense? Do you guys get it? Okay. So the next one, what do we think our w is going to be? Yeah, 3x minus 2. Kind of with parentheses. You don't have to put the parentheses around it, obviously. But then when I square both sides, then that becomes the 3x minus 2 squared. So when I rewrite this equation, it's going to look like w. Ooh, actually, I did need my parentheses because I don't want it to be. So w equals 3x minus 2 to the 2nd, right? Because I want to square it and get that first item. So instead of having squared here, I want it to be to the 4th. Does that make sense? So now when I replace, I get w squared minus 5w plus 4. And that is now an equation of quadratic type. Quadratic means x squared, like a parabola. Things you can use the quadratic formula on, right? That's why we call it quadratic equations. Yes?
Why exactly is the word quadratic used in this case?
I know. Why do they use quadratic? Isn't that strange? Because you'd think x to the 4th. I'm sure there's some reason why it's a quad. But I'll have to look it up. All right, so the next one. So it says, now that you've learned how to rewrite equations, now we're going to do this whole process again, but we're going to solve the equation. Okay, so these last ones were expressions. We didn't have an equal sign. Do you guys see that? Now we have equal signs. So we want to go all the way down to like x equals x equals x equals, okay? So the first one, I know that some of you can solve this without a W substitution. How would we solve this if we were not using a W substitution? Yeah, we would factor. And in those first spots, so don't write this, but kind of look. In our first spots, we would say x squared and x squared, right? And then we would put 4 and 1. And we do minus and minus. And then it would factor again. And we'd have x plus 2, x minus 2, x plus 1, x minus 1. So what would our 4 answers be? Nick, tell me my 4 answers.
2, -2, 1, -1.
Exactly. Do you guys see them? Those would be the 4 answers. If you guys do that on your test, I actually prefer that way. The factoring way, to me, is much faster. But I'm going to show you how to do it with the quadratic substitution, so with the W-substitutions, because our goal is not to learn how to do these. Again, it's to learn how to do things like number 6. Okay, so they get harder. They're not always this easy. So let's try it with W-substitutions, because we better get the same answers, right? All right, so if I'm doing a W substitution, the first thing I would do is I would locate what my W is going to be. So it's going to be right there. So my W is going to equal x squared. When I square both sides to see what W squared is, well, it's x squared squared, so it's x to the 4th. So this is what we were doing on those first 4 problems. So when we replace now, x to the 4th is replaced with what it's equal to, W squared. My x squared is replaced with what it's equal to, which is W plus 4. So do you guys see what I'm saying? Like the x squared was equal to W, right? The W squared was x to the 4th. So we're just replacing it. Now we factor that. So when I factor, I get W minus 4 times W minus 1. And I get answers for W. I get W equals 4 and W equals 1. But in my original problem, I didn't have W. I had x, right? So I want answers for x. So once you've done the substitution step, so we substituted in, and after you factor, we now resubstitute. So what can I replace W with?
X squared.
X squared. That's what it's equal to, right? W was x squared. So I have x squared equals 4, and x squared equals 1. That's what we're replacing. So we're resubstituting. So now we have x squared equals 4. Well, there's 2 solutions, 2 numbers that when I square them, I get 4, right? What are those 2 numbers? Plus or minus 2, right? Because I take the square root and I write a plus or minus. I never forget to write the plus or minus. So when I take the square root and write plus or minus, my other 2 answers, plus or minus 1. Did I get exactly the same answers as above? Yeah, same answers. So it's just a different way of solving these. A different way that's going to be incredibly useful for very complicated equations. All right, so the next one, x to the 4th minus 29x squared plus 100. Okay, so first we're going to decide what x or what w is. So let w equal x squared. What is w squared then? X to the 4th. That's what we wanted, right? So when we replace, we get w squared minus 29w plus 100 equals 0. We then try to factor. Who thinks they're the factoring pro? And I got this down. Yeah, what do you think, Jacob?
Oh,
Minus 25 and minus 4, were you going to give me the actual answers? You're all the way down, aren't you? All right, so I get w minus 25, w minus 4. So that allows me to solve for w. So our goal is to solve and get w by itself. We have w. Now we resubstitute. So we're going to resubstitute. And we're going to say, well, w is equal to x squared. So I have x squared is equal to 25. And x squared is equal to 4. I then take the square root of both sides. So I get x equals plus or minus 5 and x equals plus or minus 2. Those are my 4 solutions. So whatever power you have, if you have x to the 4th, you're going to have 4 solutions. Right? If you have an x cubed, you're going to have 3 solutions. Sometimes, though, those solutions could be complex, like they could have i's, and sometimes they could be they could have multiplicity, like you could have 2 as an answer 3 times, right? All right, so the next one. So I have x to the 1/2 minus x to the 1/4 minus 6 equals 0. All right, guesses on w. X to the 1/4. You guys are kind of seeing it's always that kind of that middle term, right? Most of the time. There are some weird ones. All right, so when I square both sides, I get x to the 1/4, and I'm squaring it. So I multiply my powers. So I have x to the 2/4. Well, 2/4 is really 1/2. Okay, that's exactly what I wanted. I wanted x to the 1/2. I then replace. So x to the 1/2 is replaced with w squared. X to the 1/4 is replaced by w. I now have something that I can factor. These will always be things you can factor too. I'm not going to give you ones where you would have to use the quadratic formula because that's just mean. You could have those, right? But nice. All right, so let's factor. You're like, bring it. I'll do the quadratic formula. W and W, probably 3 and 2, right? Outer and inner are 3W and 2W. We want it to make negative W, so we want the negative with the 3 and the positive with the 2. So we get two solutions. We get W equals negative 2 and W equals 3. But remember, we're not done because we need x equals. The original problem had x's. So we resubstitute. So W is replaced with what it's equal to, x to the 1/4. So I have x to the 1/4 equals negative 2, x to the 1/4 equals 3. Who would know this? Let's see. Lucy, what do you think? How do I get rid of the 1/4 power? Nothing?
I got
Claire?
How exactly do you do those?
How do you get a 1/4 power? Does it help if I write it as the 4th root of x? Now do you know? Ethan, you know?
Isn't that what that is?
Yeah?
So you kind of like use -2 times -2 times -2.
I know what you're saying, yep. So she's saying you just multiply it by itself 4 times. Well, what's that called when we multiply something by itself 4 times? We raise it to the 4th, right? So we're going to raise the power to the 4th. Is that what you were going to say, Ethan? Totally, right? Okay, good. So she's saying I'm going to take negative 2 times itself 4 times. Well, what do you get when you do negative 2 times itself 4 times? 16. Ah, is it negative or is it positive? Positive, because a negative times itself 4 times is positive. All right, so that's one of them. This is actually not going to be a solution. I know. Spoiler alert. So there's a reason that this one doesn't work, and I'll show you. All right, so the next one, what do we do? So if I do x to the 1/4 and I raise it to the 4. Yep, good. So 3 to the 4th is 81. Nick is correct. That one actually does work. So, do you remember extraneous solutions? We talked about that a long time ago. This one is an extraneous. I always say that we should have a mathematics spelling bee. Extraneous solution. Some of you guys have trouble spelling, positive, things like that. I noticed that on your homework. I fixed it. Did I fix it on yours? Was it yours, Claire? Perpendicular is always a hard one. I should have a mathematics spelling bee. Should we do that one day? Wouldn't that be fun? No, not so much. All right, so extraneous solutions. So this one, the x to the 16th, is an extraneous solution. It does not work. Okay, so basically on these, sometimes you have to check. But I'm going to show you a shortcut to avoid the checking stuff. Do we like shortcuts? Yeah. All right, so let me show you what happens when we do check. So if I check x equals 16, if I plug it into the original, I have 16 raised to the 1/2 minus 16 raised to the 1/4 minus 6. And I want to see if that's equal to 0. So if it makes it a true statement or not. It doesn't. So Jacob's saying no, because 16 to the 1/2 is what, Jacob? And then 16 to the 1/4 is what? 2. So 4 minus 2 is 2. 2 minus 6 is -4. Is that equal to 0? No. So that doesn't work. That's why this one is out. But if I check the x equals 81, and I plug it in, I have 81 to the 1/2 minus 81 to the 1/4 minus 6 equals 0. And that one does work because this is 9 minus 3 minus 6, and that does equal 0. So 81 works. Okay, If you are smart enough to figure this out, you guys can do this without the check step. I will let you on your homework. Okay, here's the trick. We're going to go all the way back to this step right here. And I want you to tell me what this means. X to the 1/4 equals a -2. Who can tell me why that one does not work? But the other one does work. Yeah, what do you think?
Is it because it's negative?
It is because it's negative, but what about, why can't it be a negative? Give me more, Ethan. It's multiplying 4 times, yeah. Something going on there. Oh, he's talking about roots. What kind of root is that?
Fourth root.
It's a 4th root. So you can take the odd root of a negative, right? But this means the 4th root of x equals -2. You can't take the 4th root of a number and get a negative out, just like a square root, right? I can't take the square root of something and say, oh, that's equal to a negative, right? There's already like a positive sign in front of it. So it doesn't work. So you can't take the 4th root of something and get a negative. So it's negative, and this is an even root. So an even root cannot equal a negative number. When you see that, then you can just stop right there and not do that side. Okay, so what if I had x to the 1/3? So x to the 1/3 equals -2. Can I take the cube root of a number and get -2?
Yeah.
Yes. The cube root of what gives me -2? -8. That one's okay. Okay, so you can take the cube root of a number and get a negative, but you can't take any kind of even root. So if you guys are smart enough to remember that, you don't have to do the check step. If you're like, I'm never going to remember that, there's no way, then you got to do the check step. Okay? Let's try some more. We have 3 more. All right, so this next one, we have 4 terms now. We're going to get everything on one side. So I have x to the 1/2 minus 3x to the 1/3 minus 3x to the 1/6 plus 9 equals 0. So previously we've been kind of picking the thing in the middle. How do you pick the thing in the middle with 4 terms? Yikes. So think about, things with 4 terms. We always split the middle, right? Didn't they usually like start out as x cubed plus something with an x squared plus something with an x to the first plus the number? So that's what we want. We want something with w cubed, w squared, w. Right, so which one is going to be our w then? X to the 1/6. Good, Abby. So we're going to let w equal this one. So how are the others related? So I have w, I want x to the 1/3. Well, what's that? So let's try w squared. You have to go. All right, let me give you your homework. All right, what is that? X to the 2/6. What's 2/6?
136.
Yep, 1/3, right? That's what we want. We want x to the 1/3. So that means that this one is our w squared. So we're good. What about the x to the 1/2? So x to the 1/6, what do I raise it to get x to the 1/2? To 3, right? So that's w cubed. So you don't have to do all this like little background information here if you don't want to. Like if you guys get that that's going to be w cubed, w squared, and so on, then leave it off. That's fine. I'm not that picky about that. Okay, so we have w cubed minus 3w squared minus 3w plus 9 equals 0. When we replace, so we substituted the w's in. Factor by what? Factor by grouping, right? Factor by grouping. This one's not really technically a quadratic type. Its quadratic equations are x squared, but that's okay. Same idea, right? We can handle it. All right, so I'm going to have w squared, and then I have w minus 3. I know I want to have a w minus 3 over here. So what do I pull out? Yep, -3. Now I have the w minus 3 in common, so I pull the w minus 3 all the way to the front. It's now my new GCF. And I'm left with w squared minus 3. W squared minus 3 is not the difference of 2 squares. right? 3. It's not a perfect square, right? So let's set each one equal to 0 and solve. So the first one gives me w equals 3. The second one, when I add the 3 over and take the square root, I remember my plus or minus, I get w equals the square root of 3, and I get w equals negative square root of 3. You guys still kind of understand? See it? All right, now we resubstitute. So w is going to be replaced with x to the 1/6. One of these we can cross out, right? This is an even root, 6th root, can't be a negative, so we can cross that one out. Now I raise both sides to the 6th. Ooh, 3 to the 6th. Anybody know that one? Good. Did you do it without a calculator? Good job, Jacob. All right, how about this one? So this is raise it to the 6th. It's the square root of 3 to the 6th. What do you think? 81? So there are two ways that you can get that one. If you weren't sure, if you're like, oh, what's square root of 3 to the 6th? You could write it out, and that's kind of what I always did in school. I was like, oh, I got to see this. I'm going to write it out. So if I wrote it out 6 times, each pair is 3, right? So I get 3 times 3 times 3. So is it really 81? Actually, it's not. It's 27, yeah. Nick, it's 27, not 81. All right, so the other way you can do it is you can think about your powers. So you're like, oh, if I have 3 under a square root, well, that's 3 to the 1/2. And then if I raise it to the 6th, I multiply my powers. So it becomes 3 to the 3. Well, 3 to the 3 is 27, right? So you could do it that way as well. All right, so yes, 7, 29, and 27. And you can check them. They both work. All right, 2 more. So next one, what do you think your W substitution is? W equals the square root of x. So W squared is just x then. So we replace. So we have w squared minus 3w minus 4 equals 0. And then we factor. So w minus 4, w plus 1. So we get w is equal to 4, and w is equal to negative 1. We then replace. So we have the square root of x is equal to 4, and the square root of x is equal to negative 1. Can we cross anything out? Yeah, the negative 1 one, right? Out. What is my answer for x? 16. Oh, I heard someone very quietly say 2 because I always trick people on the test, and I always put things that are perfect squares because people always are like, oh, square root of 4. Right, it's like they read it like across square root of, and then 4. Okay, we get rid of a square root by squaring both sides. So it's x equals 16 is actually the answer. I'm tricky, so mean. All right, so the next one. We have powers that are 5 over 2, 1/2, and 3 over 2. What's the smallest power? 1/2. We have to write it in descending order first. It makes things a lot easier. So I'm going to rewrite. So I have x plus 1 to the 5 over 2. Plus 6, not 6, hang on, minus 5 times x plus 1 to the 3 over 2 plus 6 times x plus 1 to the 1/2. And you could do this one multiple ways. So some people in the last class were like, hey, can I pull out a GCF? If you want to pull out a GCF, you can go for it. It would be x plus 1 to the 1/2, right? You could do it that way. I think it's kind of hard for my students to do that. So if you were going to guess what your W was, what would you think you would let W be? Yeah, I do 1/2, right? So how are you going to get x plus 1 to the 3 over 2? What do you think you're going to raise W to? 3. Do you see it? Because you're going to multiply the 3 by the 1/2. And then how do you think you're going to get x plus 1 to the 5 over 2? To the 5th. Yep. So we have w to the 5th minus 5w to the 3rd plus 6w equals 0. And we know how to factor this, so we can factor. So first step of factoring this, what do I need to do?
W.
Yeah, they have a GCF of w. So then I have w to the 4th minus 5w squared plus 6. And you could do a new w substitution, maybe like a u or something, or not. We'll just not do that because we know how to do w to the 4th, right? We can factor it, it's fine. So when I factor, I'm going to have w squared and w squared. I need to multiply to be positive 6, and the outer and inner swoops need to combine to be negative 5. So I need negative 3 and negative 2, yep. So I get w is equal to 0. I have w squared minus 3 equals 0, and I have w squared minus 2 is equal to 0. So when I add the 3 over and take the square root, I get plus or minus the square root of 3. So add the 2 over and take the square root, so I get plus or minus the square root of 2. Okay. These ones are the long ones. All right, now we replace. So we're like, okay, x plus 1 to the 1/2 is equal to 0. Some of you guys can do this in your head easy. Abby, do you know what that is? Negative 1, it is. She's a smart cookie back there. She knows. All right, do you guys see why it's negative 1? You're going to plug something in for x to get 0 out. It would be negative 1, right? If you're doing it the long way, we square it, subtract 1, subtract 1. Do you guys see it? So yeah, we get x equals negative 1. All right, so this is x plus 1 to the 1/2 equals root 3. You could do plus or minus root 3, but minus, you have a square root equaling a negative, right? So that one's not going to work. How do I get rid of the 1/2? Square. So when I square both sides, I get x plus 1 equals not root 3, just 3. So what's x?
2.
X equals 2. And then same thing over here. So I have x plus 1 to the 1/2 equals square root of 2. Square both sides. So I get x plus 1 equals 2. So x equals 1. Those are your 3 answers. 1, 2, and negative 1. Done. Okay, kind of tricky. You guys got 10 minutes to start on your homework, so try it and see how you do. Let me stop this and I'll come over there.